Hello, students. Today we are going to see some more interesting and important questions from PYQ. Come on, the first question. Which one is most reactive towards nucleophilic addition reaction? Nucleophilic. See, nucleophilic means what it is? Electron rich category, right? Okay, now here they have given the option benzaldehyde, acetophenone, and toluidaldehyde and nitrobenzaldehyde. Yes, this is toluene and aldehyde group which is attached, that is toluidaldehyde. Generally, aldehyde group which is most reactive towards addition reaction, that is nucleophilic addition reaction, whereas keto group, this is keto group, C double bond O. So this keto group which is having a steric hindrance, generally aldehyde, it is more reactive than ketone, right? So though it is aldehyde group, this is keto group, keto group is there, but in this keto group steric hindrance will be available, steric hindrance, so this will not be applicable. And the next one, this is CH3 and this is NO2. Of course aldehyde it is there, no problem, but here what it is attached with that, here electron donating group, whereas here electron withdrawing group. So here I would like to mention all these hint points, that is nucleophilic addition reaction is directly proportional to charge on carbon atom and directly proportional to electron withdrawing group. So electron withdrawing group is there means it will increase the nucleophilicity, and indirectly proportional to electron donating group. So electron donating group, if it is available, so that will not be favor for nucleophilic addition reaction. And another one, it is inversely proportional to steric hindrance. Steric hindrance means here keto group is available, no, so that will not be the correct option. So in that, among aldehyde it is a common, but keto group it will not come at all. And next one here, here aldehyde group it is there, but electron donating group it is there, so this will not be present. Here aldehyde group it is there more than aldehyde, here electron withdrawing group it is there, so electron withdrawing group increases the nucleophilicity. So which is the correct option? Option D is the correct option. The next question, treatment of cyclopentanone. This is cyclopentanone structure with methyl lithium gives which of the following species? Options given: cyclopentanoyl cation, cyclopentanoyl radical, cyclopentanoyl biradical, and cyclopentanoyl anion. Right, now here cyclopentanone, this is the cyclopentanones, that keto group which is attached over, right? So automatically due to that electron transformation, here minus charge it is taking place, so the minus charge which is attracted by the positive charge, where there is a positive charge, methyl lithium, lithium it is a positive charge and methyl it is a negative charge. So this positive charge which is attracted towards that, what it is, minus charge of keto group due to the transformation of electron, right? So here what is the product you will be getting? This is a positive charge and this is a negative charge. So this negative charge only, anion, is it called anion? It's called anion. So anion only is the correct point, but here cation will not be the pentanoyl keto group, it is a minus charge transformation, it is taking place minus charge, so cation will not be the correct answer. Radical, which will not be coming radical, it is Cl2, when it gives Cl, here also Cl, so this is a radical, only one electron, it is a radical. So this also no, biradical will not be the correct option. So anion it is the correct option. That anion, then which is that anion? Cyclopentanoyl anion is the correct option. So like this question you will be getting n number of questions, but you see the concept, how do we identify that answer in that way. So which is the correct option? Option D is the correct option. Hope you got the clarity. Come on, let us go to the next question. It is really interesting and it's easy also. Total number of pi bond electrons in the following structure. Pi bond electron, it is totally different from pi bond. See, generally here, before going to this question, I just mentioned all these points so that it will be easy for you to understand. See, sigma bond due to s orbital, pi bond due to p orbital, and here sigma bond, it is a single line, single bond we can say. Pi bond, it is a double line. And triple bond. So triple bond means what it is? One sigma and two pi bonds. That is triple bond. Yes, come to this point. Here they have given one product. That means they have given one compound. In that, how many pi electrons are there? Now we have to identify. See, pi bond is different from pi electron. So pi bond, that is equivalent to 2 electrons. So this is pi bond, means one sigma bond, one pi bond is there. No? So that means it is equivalent to 2 electrons, right? So how many 2 electrons are there? That means here one pi bond it is there, and here one pi bond it is there, and here one pi bond it is there, and the last pi bond. So how many pi bonds? 4 pi bonds are there, right? So 4 pi bond into 2 electron, right? So 8 electrons. So total 8 electrons. Option A is the correct answer. Hope you got the clarity. Please note down 4 pi bonds. Pi bond is different from pi electron. Pi electron means what it is? How many electrons in that pi bond? That means 2 electrons are there. So totally 4 pi bonds are there. 4 twos are 8 pi electrons are there. Got it? Come on, we'll go to that next question. The next question, which of the following is the most correct electron displacement for nucleophilic reaction to take place? See, whenever we are doing for mechanism, this really will help you to identify the correct point. See, in that first option, CH3, CH double bond, CH2Cl. Here, in this point, nucleophile which is going to attack. So, when that nucleophile attack, so that pi electron transfer here. So, here I have given this point. So, the pi electron transfers means here minus charge will be coming. But here nucleophile which is going to attack, there is a minus charge they didn't even mention. And how is it possible the electrons are transferring to this side, left side, means how is it possible that right side Cl minus is going away, and it has not mentioned the minus charge over here. So I just mentioned that point. And the second question, second option, CH3 CH double bond C H and CH2Cl. See, when that nucleophile attack, I just mentioned green color. So, nucleophile attacks the electrons, pi electrons are transferring. So, due to the transfer of electron, so automatically Cl will be removed. So, that is what I just mentioned. When the electrons are transferring, I am putting minus charge. So, automatically the double bond goes over to the next adjacent atom. Then Cl it has removed. Actually, it's a correct way of mentioning to that mechanism point. And the third option, CH3 CH double bond CH CH2 Cl, and when that electrons are transferring, that is displacing. So here displacing it is there, but they did not mention that Cl it is going away. It has to mention, but here it is mentioning correctly. But here Cl has to be removed. They didn't even mention. Why? Because adjacent orbital it will be removed. That Cl it will be removed. So, but here they did not mention in that point. And the last one here, nucleophile attack, where there is attacking taking place only, they didn't even mention. Then how is it possible for Cl will be going away? It has not mentioned the transfer of electron. It has to be mentioned. No. So nucleophile attack also not mentioning, and transferring of electrons also they are not mentioning. So this will not be the correct. See, from this question you will come to know how you have to move that mechanism while writing. You have to be very careful, the transfer of electron, minus charge, and removal atom. So these are all very very important. So option 2 is the correct statement for according to these four option. Option B is the correct option. Yes, come on, let us go to the next question. Here they have given three compound. In that, what do we identify? Here hyperconjugation. In which compound is having hyperconjugation? We have to identify. But they have given what it is, free radical. Now, in that free radical, where do we identify the alpha hydrogen? In that compound it is applicable for hyperconjugation. That's all, very simple thing. You know very well hyperconjugation means. In this compound, how do we identify? That's what purposely I have given. Delocalization of sigma bond or sigma electron with p orbital of carbon, free radical, which has only one electron to the p orbital. So for this, which is the main important condition, it has to contain alpha hydrogen. Now, which is having alpha hydrogen, you know very well. Okay, let us identify, is there any alpha hydrogen? So this is for this compound, first compound, there is a free radical. In that, where is a alpha hydrogen? You cannot find any alpha hydrogen here, which is attached with phenyl group. So this also does not have alpha hydrogen. Whereas here phenyl group, which is attached phenyl group, you cannot identify that alpha hydrogen. So CH, that alternative double bond only it's available, right? So you here also you cannot find any alpha hydrogen. Whereas here bridged compound, in that bridged compound, here one alpha hydrogen it is available and here one alpha hydrogen is available. So only third compound it is applicable for alpha hydrogen, which is regarding for what you are asking, that hyperconjugation. So only compound 3 only is having alpha hydrogen. That means this compound is applicable for hyperconjugation. So this hyperconjugation occurs only in this compound 3. Where do we identify that alpha hydrogen? Where there is next to that adjacent atom of free radical. Now this is the free radical carbon. So next to that adjacent carbon, there is hydrogen is there, no? So that alpha hydrogen. Whereas here, is there any alpha hydrogen? Hydrogen is available. This is the free radical. Is there any alpha hydrogen? No, not at all. And here also the same. So which is the correct option? Option 3 is the correct option. Hope you got that idea. Come on, let us go to the next question. The enolic form of ethyl acetoacetate has shown below. So in that you have to identify how many sigma bonds and how many pi bonds. As you are looking at the compound only, you will get two pi bonds. It is a mandatory. Two pi bonds are there here and there, both the side also. So nothing to worry about that. But when we are going for sigma bond, you have to consider each and every bond. That means each and every atom which is attached to that carbon. So that is around. So I'm giving a simple trick for you. This has given from my guru. My guru has taught this to identify the sigma bonds. That is only for aliphatic, not for aromatic. Benzene ring and all, you cannot use this formula. Only you can use aliphatic compounds only. Okay, to identify the sigma bonds, number of carbon minus 1 plus number of other atoms. So how many carbons are there in that minus 1? So that means how many carbons are there here? 1, 2, 3, 4, 5, 6. 6 carbons are there minus 1 plus number of other atoms. So number of other atoms means what it is? What are all the atoms which is attached to that carbon? Now here 3 and here one oxygen, 3 hydrogen, 1 oxygen, and here 2 hydrogen, and here 1 oxygen, and here 5 hydrogen and 1 oxygen. So altogether here 3 plus 1, 4, 5, 6, 7, 8, 8 plus 5, 13, right? So here 5 plus 13, how much? 18. Now you check it in this way also. Now for suppose if you are going for this side also, how many carbons are available? The same, 1, 2, 3, 4, 5, 6. 6 carbons only is available. And the same way, how many other atoms are available here? 3, 4, 5, 6, 7, 8. 8 plus 3. Sorry, 8 plus 5. So that is 13. So 13 plus here 5. 18. So 18 sigma bonds are there. 2 pi bonds are there. Correct option is option D is the correct option. So 18 sigma bonds and 2 pi bonds. Hope you got the clear idea about this formula. You can utilize for any other compounds, only for aliphatic compounds, not for aromatic which will not be, that we will use it for Huckel's rule, but here we are using this rule. So number of carbon minus 1 plus number of other atoms. So this will be applicable to find that sigma bond only. Hope you got the clear idea. Come on, let's go for the next question. In which of the following compound the carbon and chlorine bond ionization shall give most stable carbonium ion? When we talk about carbonium ion, carbocation stability, it is directly proportional to plus M plus I and plus Hc, that is hyperconjugation. Generally, it's a common known fact. Carbonium cation, it is tertiary, secondary, primary methyl. It is a common, well-known answer. So in that way, compound A, B, C, D. Let us check it. So in this is a leaving group, right? So this is a leaving group. So this is a tertiary carbocation. This part it is tertiary carbocation. So tertiary carbocation, how many alpha hydrogen is available? 9 alpha hydrogen is available. Whereas this is benzyl chloride. So this is a leaving group. So that means here 2 alpha hydrogen is available. Right now here, this is what it is, electronegative group, electron withdrawing group. This is also leaving group, right? Okay, now here how many alpha hydrogen is available? Here also 2 alpha hydrogen. See, that means this part, so this one and this one. So 2 alpha hydrogen is available. Whereas here in this, how many alpha hydrogen is available? So this point and this point, so that means 6 alpha hydrogen is available. So that means which is the highest, most stable. It's already known. From this point only helps you to identify the correct option. I hope you know the answer now. Option A is the correct option. Why? Because carbocation, which is tertiary carbocation, is more stable than, most stable than anything else. I hope you got that idea. So let us go to the next question. Following is not the product of dehydration. See, this is a compound. What is the product which is not that product of dehydration? See, generally when we are going for dehydration, H plus OH minus. So H plus and OH minus. So automatically this OH will go away. So that means here what happened? Carbocation will be there. Again, that it is removal of H plus ion. So the product will be, which is not the correct option. First and foremost, which is the correct option? Let us check. So in this, see the product, you will get what it is, OH. If it is leaving, automatically you will get that carbocation over here, tertiary carbocation, that is most stable, right? This is most stable carbocation. Okay, now when we are losing that H plus ion, one thing here, you may get the double bond. This part you may get the double bond, or else you may get the double bond next to that adjacent carbon, or else next to this part you may get the double bond. So any one point which is losing that double bond, that means which is losing that bond, and you will get the double bond. So in that way, three products also, which is possible product I have given. So H minus, that means one hydrogen if we lose. So automatically this point, the adjacent carbon. So adjacent carbon, it's getting what it is, double bond. Or else, see here that this carbon, this point you will get the double bond. Or else you may get this point which is connected to that carbon, where there is a carbocation which is connected to that carbon, you will get the double bond while losing H plus ion. which is not the product, so the double bond will not go inside that, what it is, hexagon. This will not be the correct answer. It will not be applicable. Why? Here only that, what it is, carbocation it is coming. So carbocation, if it comes here, means which is adjacent, this point you will get it, or this point you will get it, or this point you will get it. Only these three point you will get the double bond, whereas this is next to that carbon only, so this will not be applicable. Okay, so which is the correct wrong option? D is the correct wrong option. Whereas this is a correct as we mentioned this point, and the same way this is correct as we mentioned this side, and this is correct as we mentioned this one. I hope you got the clarity about this. So first, if you know the concept, you can identify whichever it is correct answer only directly, right? Hope you got that idea. Come on, let's go to the next question.